Okay, so today we're focusing on Chapter 4, Exercise 5. We'll first go over the creation of this image by a turtle. This is our code. We're going to set up our turtle with a light green background and a blue pen color. This is all pretty standard. We're going to focus in on our function, which has 4 variables. Which turtle is drawing it, represented by T, SZ, which is our side length of the square that the turtle is currently working on, N, that's the number of sides drawn, which will actually be multiplied by 2, which we'll see why that's the case a little bit further down in our code. Size increment, this is the incremental increase of the side length. That's described here in our comment. We also include, to make a perfect square, you'll want to set our side length equals to the side increase that you're making. The code is going to run if size increase is greater than or equal to size. Else, you'll get this error message, which we'll print out first just to show you how that works. Okay. So our turtle is set up on our green background with our blue turtle, and it won't run. Sorry, that won't work. Please enter a new size increase. Size increase must be larger or equal to size. That's because it won't produce a viable spiral. So let's close idle here. So the next thing we're looking at is our if statement. So let's correct our size increase to the correct size. So here we're setting our side length equal to the size increase, so we should get a perfect square. Going through the code, the turtle will start by turning right 90 degrees, then going forward side length, and then right 90 degrees, and then forward side length. And then at the end of this time, our side length will be increased by size increment. That is why the number of sides drawn is n times 2, because according to our range, it'll go through 2 lengths of the side before repeating. Our range captures that. Let's run our code. Okay, so we get this nice concentric squares. And what's important is that the size increase is a constant amount. If it were variable, let's say increasing as size was multiplied by 2 each time around, what you'd get is an expanding spiral, not something that that increases by a constant amount each time. You'd get something that looks much more like a spiral pulling back and getting wider and wider, and that is not the result we want. That's why it's so important that size increase remains a constant amount. Part B, we're looking at a spiral with a turned angle. Putting the code side by side, the only change is right here. So on this line here on this code versus here, we've we've added a 5th variable, that's turn, increases the angle of the spiral by turn amount. So you're able to vary how much you want the spiral turned. Here we're only increasing it by 2 degrees for our run. Let's see what that looks like. Oh, sorry, wrong code is run. Run module. Great, so we have something that matches this first picture. And again, the only part that we're varying really is the amount that the turtle turns at its second turn. The last thing I want to focus on that I think is interesting is the size increase. Again, this is what we are trying to produce, is this perfectly concentric squares right next to each other. But let's say size increase was not there. Let's say it was a constant amount or not, it was not a constant amount. It varied based on size. So let's say it's size plus I, right? It's increasing every time I is increasing. Let's see what that would run like. So I'll pull this down to a lower amount. What would be our effect? Oh, oops. So you see here that at each turn it gets wider. It's like a perspective drawing. We can exaggerate that more by making it size times 2. So that's, well, now it's too large, but that's not really what we wanted. What we want is that the incrementally increasing by a constant amount in order to get the correct result on this page. That's it. This is exercise 5 from chapter 4. Thank you so much.